positive and negative. Pag sira mo dito, ano mangyari? Makakikita ka ng forward or reverse bias. In this case, it should be low reading. Okay? It is reverse bias. This is high resistance. The other way, if you reverse this, okay, tapos ito dalhin mo dito, ito dalhin mo doon, this is going to display a low resistance. So in the same all in this direction. Okay, so ganyan ang pag-testing ng, so pag ganyan ito, plus, minus. Because this is plus, connect this, and this connect this. This is going to be low resistance. If reverse it, ito dalhin mo dito, ito dalhin mo doon. This is going to display a high resistance. So the same way here, because what is to be noted here is only the junction. We're actually testing the junction between the base, the emitter, and the collector. Okay, so ganyan ang pag-test ng magtatanong ka kung how do you test the vacuum tube, by the way? Because the vacuum tube, as we noted, the to test the vacuum tube, since it only works with the presence of heater, ininit mo yung plate, tapos ininit mo yung grid, tapos ininit mo yung the only time that the vacuum tube becomes defective, the metal, this cathode, this plate, grid, and this plate, they are solid materials. They are solid metal, and inside is vacuum. So it appears there is no way for it to be, there is no way for this to be busted. So the only indication when vacuum tube is busted is the filament. A dead filament causes the malfunction. Kapag mahiling mo ang filament kasi nagliliwanag yan, garo nag-glow, may baga sa loob, saka siya makikita. Kapag wala ng ilaw, dead filament, meaning to say no light, no, umiilaw yan it's not glowing. Pag hindi nag-glow, patay na yan. Siyempre, hindi na yan magkakandak, hindi na yan magpa-function because hindi na naiinit ang cathode. Ang source ng electron, pag hindi na nainit, hindi na mag-iinit ng electron, no matter how big potential is present between the plate. If the potential is so big, then what the result is that it's just going to burst. Another indication of bad vacuum tube, you will see that this is a darkened enclosure. Kung dark na ini enclosure na ini, okay? Darkened tube, filled with oxide makes the vacuum tube bursted. Okay. Anyway, I'm sure you are not going to encounter this vacuum tube in your when you work. But if you become interested in listening to good music, kung magkaigwa ka nin appeal magdangog sa music na very clear, very very pleasant to the ears. You will experience this only when your amplifier is made up of vacuum tube. Although ang mga semiconductors napapalabas din, but semiconductors in the States is very expensive. Ang amplifier na kay puwan mong bakalon tanganing mag-produce ki sound na malinig tapos pleasurable pagdangogon can cost you about pinakamura na ngayon ang 30,000 pesos. And there is even a cost of one amplifier which almost cost 2 million. Think about that. So, ganyan kamahal ang electronics. Okay? So, remember that you make sure the test instrument, itong meter, itong meter, 0, okay, infinity. Ito naman, pi, infinity. Ito 0. Remember, make sure to use the Ometer for testing diodes and transistors. Good result is availed when the internal battery of the instrument is good. Kung discharge ang battery mo, sabi ko nga ito, may battery yan. Pag discharge ang battery mo, wala na yan. Hindi na yan that cannot provide the right bias or the right current in order to attain the forward bias current to trigger the conduction of the diode. Okay? Now, any question with regards to testing of the you have any question with regards to testing the diode and then transistor? Now, I told you before to study the biasing, the three main biasing configuration of the transistor. That is, you have the emitter, common emitter, common base, and common collector. So, let me share to you another another item from the internet. This is from the internet. What I'm going to share to you is another thing from the net. Hindi na kailangan magpara gawa ka ng available na eh. Uh, okay. What you have here are the different way to bias uh, the transistor. Again here, this is a common base bias. Take note that in the common base bias, kaya nga common, dahil yung input, okay, yung input signal is common at the base with the output signal. So, tingnan mo, ang output signal has a battery which is the positive polarity is connected to the base. And the input signal has the battery in which the negative polarity is connected to the base. So this is what makes the transistor to be called a common base transistor. Since the input signal is through the emitter and then collected at the collector. Take note that here, the VBE, the base emitter voltage is very small compared to the base collector voltage. Okay. Now this base collector voltage, if this is very big, is what determines the amplification factor of the transistor. Remember that only a small voltage is necessary in order for the base and emitter to conduct. So let's say, for example, in this case, you only need about 0.7 volt. Okay, maybe let's say a little bit higher, maybe somewhere here, say 0.7 volts. So it's already in the highest conduction electrical current conduction rate. So that means with just a 0.7 volt present at the base, you will be able to trigger the conduction at higher voltage at base and collector circuit. So the amplification now takes place such that it is the ratio of the current, collector current to the base emitter current. Okay. If you take note of the direction of the current from the emitter goes into the transistor. The current in the base goes out. So it appears that the total current of the emitter equals to the current of the base plus the current of the collector. But since the emitter current is very small, being it is being triggered by a small voltage, so its amplification will be a big factor. Malaki ang magre-result na amplification. Now, the graph here represents the conduction characteristic of the terminal, current in the terminal. In this case, this is the collector current, I sub C. Look at that, this characteristic of the current. It goes to 5 amperes, 10 amperes, 15, 20 amperes. Whereas, in terms of milliamperes, whereas it is only being triggered by a small amount of voltage at the beginning of the conduction. In this case, if this is 5, so somewhere here, conduction takes place and the current is already goes to about 5 milliamperes. Now, pag susugon mo ini, this is somewhere here, this goes to about a little bit more than 1 volt, so that the maximum current 20 milliampere is almost reached. Okay. Now, the next configuration is the common emitter configuration. Take note in the common emitter configuration. So emitter ang naging common sa both base circuit and the collector circuit. Yung pagkakaiba, yan o. So, the base here is common. The battery is connected. Two batteries at the input and the output is connected at the base. In here, it is in the emitter. So the input is introduced into the base and the output is collected from the collector. The same way as of the common emitter, common base, the output is collected at the collector. Ayan. So this is the common common emitter. Now, you the difference, by the way, the difference in this case is the amount of current always. If you note, compared with the common base circuit, we can expect that this current at the emitter can be high. Okay, can approximate the current that comes out of the collector. Okay, so the base, what the base has just to do is only that it needs to be the source of the trigger in order for the emitter and base to be set into a forward bias condition, so that the signal coming from the emitter getting into the emitter must pass through the transistor and be collected to the collector. Now, in the common emitter, the signal is fed into the base. So as long as the base and the emitter is forward bias, this characteristic of signal can be reproduced at the collector. So here is now the characteristic of the collector. Yeah. Okay. Take note that somewhere at 0.6 or near 0.7 volts, or close to 0.67, 0.5 to 0.67, or getting close to 0.7 volts, conduction now starts to go up. While when the voltage at emitter and base is just about 0.4 or 0.5, conduction is still not present. Okay, so, and this is now the output characteristic as obtained from the collector emitter circuit. Yeah. You take this graph, the input of the collector and the input of the emitter, the voltage of the emitter. Siyempre, take note that the current here is only in milliamperes. Again, we cannot expect that the current here will be a very big value, because in the first place, the latest structure of the material that is used is only dupe. Kumbaga, inalter sa natanganing magkaigwa ki excess electron and excess proton. That's why the current carrying capacity here is only in milliampere. Unlike now when you study electricity, wherein your conductor is made up of solid metal like copper or aluminum. So it is able to conduct current in the amount of maybe even hundreds or even thousands of amperes. But here in electronics, you're only talking about milliamperes. Okay, yan ang pagkakaiba nito. Now, what are the characteristics of the common common emitter? So these are the characteristics there. Now the next configuration is the common collector. Okay. Take note here, the common collector. Okay? The load in the common collector is obtained at the base, at the circuit of the emitter and then the common to the ground with respect to the base. Okay, where the supply voltage connects directly, it appears that the supply voltage is interface with the collector because of the circuit. So the final output, the complete loop of the source of the output, the battery output, is connected to the collector and obtained at the emitter. Again, the trigger is still being introduced into the base. So kung merong trigger dito sa base, magpo-forward bias yung base and emitter so that the current from the collector to the emitter through the junction transistor will be available. Okay? So this is a so just take note of the configuration of how the battery is situated so that the biasing is identified. Okay, so tingnan mo ang mga picture na ito. The base is common to the emitter, but the supply voltage of the output is connected to the collector. While if you compare in the other, so the load is at the emitter here, and the load resistor is at the collector. So the same way with the other side. Yeah. It is at the base, the battery is at the base. Okay? So, yan. The, so these are the given condition. And here is presented the characteristic of the signal. Take note here that when the input is positive in the ongoing positive signal, the output turns out to be negative. The signal at the input is in inverse out of phase with respect to the output. Kaya kung dito pataas ang signal going positive, sa output is going negative. So naging reverse. That is when this configuration is common emitter, whether the transistor is NPN or PNP, the input signal is 180 degrees out of phase with respect to the output. Now here in the common base, it appears that whatever input is present at the emitter, the same will be present at the collector. Okay, that's for the common base. Take note that the common base often is being used for uh, voltage regulation circuits. Why? Because the current here at the common base the current through the emitter is almost the same as the current at the collector. If if you remember the some of the currents, so tingnan mo. The current at the common base, the input current is equal to the current at the base plus the current at the collector. So it will turn out that if only very small current will be needed by the base to forward bias the collector, the collector current is just a little bit smaller than the current at the input. So the current at the base is small. Most of the emitter current here will go to the collector current. So dito naman, dahil ang direction ng most of the current I sub C goes to the transistor. So the emitter current is equal to the collector current plus the base current. So what does this imply? If bigger amount of collector current leaves the source at the emitter collector circuit, therefore the base current is here is only small. Okay? Kasi maliit lang ang so by inspection, mahiling mo na ang emitter current still the biggest current in the circuit because that is the sum of the base current plus the collector current. Okay? Ito naman, para maka-obtain ka ng non-inverting output, ito ang ano mo, common collector ka. Kung ang input, kung positive ang input ng base, dahil NPN, ayan, positive ang value output mo. So the same way when it is PNP, okay? Pagbaliktadin mo yan, ganun din mangyayari. Now, we are fond of defining the gain. We say the gain is just the ratio of the current at the output over the current at the input. In this case, for this common base configuration, the gain is equal to the change in the current at the collector over the change in current at the base. So ito ang formula. We call that current gain as beta. The beta is the current gain at the collector with respect to the base. Okay. Now we have another alpha, that is the current, the change in current at the collector with respect to the change in current at the emitter. That's the alpha. This common base, this beta is applicable for a common emitter circuit, while the alpha is applicable for a common collector. Okay. Now we have another gamma. Gamma is just practically the ratio of the emitter and base current. Dito, mula dito. Yung unang collector to base, sunod collector to emitter, and then yung gamma is emitter to. So pag kinuha mo yung mga ratio niyan, this is the result of alpha as also a function of beta over beta plus 1. Well, you can easily derive this formula. Just remembering the factor of gain to be the ratio of the output over the input. Okay? Take note that for the common emitter, balikan natin yung common emitter. Ayan isa. The common emitter, the output appears at the collector. So it is the input appears at the base. That's why the beta gain is collector over the base current. Ayan. Okay, so hindi naman ito masyadong mahirap na formula kadakot. Just derived from the input-output. By the way, we discussed in the other class, we already discussed the photocell, actually a photosensitive semiconductor. The symbol here, this actually represents a transistor, but there is no physical terminal for the base. Instead, the base is being activated or being triggered by the light. Itong arrow signifies the photon hitting the part of the transistor. When the photon or light or visible light hits the portion of the transistor, that initiates conduction because some of the electrons in the field in the semiconductor is being displaced. So once these electrons are displaced, that forms the forward biasing necessary for the base to bring it into conduction. Okay? So pag nagkaroon ng init, magkakandak itong base na ito, at finally, there will be an avalanche of electrons between the collector and the base, and then the emitter to prolong, to allow a continuous flow of current between emitter and collector. Kaya, nauso yung mga photocell sa atin, mga tawag niya, uh, photocontrollers, because of this. Yeah, and if you take a look at this small item, it is as small as this. Okay? So, yan. Ito naman, optoelectronics na tawag. Para mag-conduct itong transistor na ito, kailangan ng light emitting diode na nasa loob. Ano ang purpose ng light emitting diode? The light emitting diode serves as a trigger. Para pag na-forward bias itong diode na ito, mag-i-emit ng light. Yung light na in-emit, tatamaan ng junction ng transistor dito at saka siya magko-conduct. So ito ng output. Take note that this configuration has 4 terminals. 2 terminals for the light emitting diode, 2 terminals for the active transistor operated by LED, light emitting diode. Ito naman, this is another configuration in which it is a switch, actually that is a switch, and it's operated by means of the presence of light. However, the light do not directly hit because the light is being produced by the diode that is built inside. Nasa loob ang diode na ito. Pag na-forward bias ang diode because of the input signal, pag na-forward bias, saka na ito magko-conduct. So, it forms the function of a switch, and the switch is being operated by a visible light. So that when there is the presence of visible light that is tuned to the frequency, the junction will be activated and causes the arms. In this case, the collector and the base is switch on. So here is another simple diagrammatic example of the. Take note, what is the purpose of E? This is a resistor. This is only for the purpose of dumping the current at the excess current at the load. Because once the transistor here behave as at the conduction state, kumbaga pag nag-on itong transistor na ito, it will appear to be like a closed circuit, kumbaga sarong physically switch such that the resistance between the collector and the emitter is very low. And the load will be created at dito between this point and the ground. So ito papunta ulit sa ground. Now R sub E is the resistance at the emitter. That is the emitter resistor. What is the purpose of the emitter resistor in that case? What do you think is the purpose? Okay. The purpose of the emitter here is to be able to produce the bias necessary to make it available at the junction between the collector and then the emitter. Kasi kapag nag-conduct ang transistor, itong output na ito ay magiging voltahe ito ng BCC. Kung mabawasan niya ng small potential, the potential will be the voltage drop across the junction. A little less than 0.7 volts. So if the potential between voltage, the BCC here and ground, let's say 12 volts, what you will expect from the output can be a little bit less than 12 volts, but not below 11 volts. Because if the potential between the ground and the BCC is exactly 12 volts, and the loss of 0.7 volts for the forward bias between the positive negative junction is 0.7 volts. So your output can be as low as 11.2 volts. Meaning to say the remaining 7 volts is left here. Okay, dissipated at the transistor. So ganyan yan. So another operation of the phototransistor, actually this is the optocoupler. Why coupler? This operates in which when there is a switch, a mechanical switch this time, so that there is a source of DC source. If the switch is put on and off, on, off, on, off, the diode will light also on, off, on, off. And so the output of the optoelectronics, ito, will also be on, off. So kung nilagyan mo, nag-signal ka nito, let's say S o W, ano bang S? Ang signal ng S. Halimbawa, nag-signal ka ng SOS. Okay, so the light will trigger an SOS light so that this is going to be on and off according to the sequence of that code. So, ito na yung battery. Ayan. Kaya, ang output dito mag-on according to the kung naka-on ang LED. Okay? Now here we have a unipolar transistor. I have to just read this. Look at that, the symbol is different. Okay? Again, a unipolar transistor is just a junction field effect transistor. It is a junction field effect because practically the gate has no electrical continuity with respect to the drain or source. The gate is introduced there to just allow a charge to be present. Ayan, okay. So walang direct conduction ng current dyan. Ang direct conduction ng current dito is from the drain to the source. So sa the gate, wala. Ayan. Unlike in the field effect and the junction bipolar junction transistor, the current is so a little bit big. If you compare the current necessary for the field effect transistor to bring out to conduction, the current at the drain at the gate is very small. Ang gate dito, yun ang equivalent dun sa base. Okay? Yes. Anyway, ito yung diagrammatic construction niya. Take note that the gate practically do not have any direct contact with respect to what the gate needs is only to produce the field. Kaya pag nag-introduce ka ng positive charge dyan, at ito negative, ano mangyari? Parang hinihinaan mo ang flow ng positive papunta doon sa source, punta sa drain. Okay? Kasi lumaki ang daanan. Lumiit ang daanan. Pero kung palaki ang daanan, yan. Ayan ang construction niya. So I just want you to read about the characteristic of the transistor. Okay, now, in the circuit here, we already eliminated the presence of the battery to be connected individually between the collector and the base circuit, or the base and then the emitter circuit. So what we can see here is that there is just a voltage divider present between the collector and then the base. And then the emitter, and then it will divide. Ayan baga. Because in any electronic circuit, isang set ng battery lang makikita mo. Hindi yung gaya ng kanina. Merong battery connecting the base emitter, merong battery connecting the base collector. But in the actual circuit, there is just this methods of biasing. You will note that it's only a configuration of a voltage divider. Okay. Well, we already discussed this now. This is how your transistor appears. Now, the 7879 is actually a voltage regulator IC. Actually, this is not only a transistor, but this this item composes of several transistors inside na maliliit na transistor. We have the 79XX, 78XX. The 79 is the code of the IC regulator. The last number, the XX, that tells what is the regulated voltage. So if this is 7912, that means the regulated voltage is 12 volts. For 7912, the input will be negative. Okay. So this is a negative regulator, 78 is a positive regulator. Okay. Yan ang pagkakaiba niya. Ayun na. Now, this is now the circuit of the, wherein both the input and the output are provided with filters. Pag hindi mo yan nilagyan ng filter, mag-aham yan. Magkakaroon yan ng ingay. Also, the filter, the capacitive filter here serves as the surge protection for the input. Para pag naano siya, hindi magbabago ang ito na yun. Okay, so here it goes. Yan. Now here, look at this. In the base circuit, there is an adjustment. The purpose of the adjustment is to adjust the output. Pwede mo yung baguhin. Here is now the relationship of the voltage out with respect to the ratio of the transistor R2 and R1, this one and this one, in order that the output voltage will be defined. Now here, this is a single stage common emitter amplifier. Okay, common emitter kasi dito yung emitter ay naka-ano. So the entire circuit for the output, this is the output circuit, itong kung ito. The entire output circuit with respect to the base is common to the input circuit with respect to the base. Kaya bagay ito, common emitter. Kasi yung emitter is common on both the input and then the output. Ito yun. Ito na yung circuit ng output. Ito yung circuito ng input. Okay? So what is R1 in this case? Ano ang purpose ng R1? Take note that this R1 meets at the common junction with R2 and with the C1. Okay. And R1, one leg connects to the BCC positive, R2 connects to the negative. Okay. Now, R1, R2 is actually a voltage divider. So that voltage divider provides for the stabilization of signal at the base. So that without the input signal, kung wala itong input signal dito, it's either the transistor is on or off. Depende sa bias nito. So kung in-on mo, maybe you provide a higher 0.7 bias between emitter and collector. Ayan, mag-on talaga yan continuously. Now, ito na ngayon ang translate function. The translation function of the signal. Ito pumasok na signal, and ito ang lalabas na signal. Ayan, tanang representation. Okay, maybe I will, hindi ko siguro i-share yung o kaya napon na lang nindo. Para yung ni-lecture ko mahanapon nindo, pwede na yan. Okay, so we have the idea now. We can picture out what is the transfer function of the signal from input to output. Here is it is reflected. Ito yung input niya, ito yung output. Itong output, yun yung waveform na makukuha mo dito. Kung ano ang output dito, yun ang lalabas dito. Tingnan mo. Kung nagsimula siya sa sa pataas, pababa, dito pa from left to right, dito na from low to high. So inversely ang inverse signal ini. Okay? Again, whether it is inverse or in phase or out of phase depends on the configuration of the circuit. So, yan. As you say, we have the voltage gain. So mga tinatawag natin na gain. It's just the ratio of the input-output of the in the circuit. So in this case, gain A, take note that the voltage B, the ratio at, it can also be expressed as the ratio of the resistances at the collector. By the way, you may ask, how many ohms will be present between the terminal of the collector emitter, or collector and base, or base and emitter? Practical, I say it only needs 0.7 volts in order to be forward bias. So the resistance there is in the range of less than 10 ohms. Okay. Now, in the process of conduction, because we have the so-called bandwidth, ang bandwidth dito ang tinatawag na bandwidth. In a certain frequency, there is a starting point in which the signal will rise from 0 going up and then go down to 0. Now we are interested on the half power point, such that from the highest of the peak and then going down on both before or after, there is a decrease of 3 decibel. Okay, so what is a decibel? A decibel is 1 decibel is equal to 10 bell divided by 1 bell divided by 10. The bell, kaya bell yan, yung tawag niya na bell is representation of the sound. The sound, in order for it to be measured, it is expressed in bell, because the circuit for this before was used for sound reproduction. So the bell is adapted in order also to express the gain, the ratio of the input and output of the. Now 1 bell is equal to the logarithm of the ratio of the output P2 to the input P1. It is just appropriate that bell is adapted because the characteristic of the conduction is logarithmic. Okay. Anyway, so it will be convenient to use logarithmic value, because logarithmic value can represent a very big number. Just to be a big number can just be represented by a small number in terms of ratio. Okay, so if you get the logarithm of the ratio of the output power to the input power, that is the bell. Okay, so if the power at the output is positive and the input the same positive, we get the logarithm of the bell to be positive. Pero kung output power ay negative, mababa ang output kaysa sa input, you will find that the bell or the logarithm of that is negative. Okay? So if we start at the highest power and then go down to the lowest power, you will note that it will be at negative 3 bell. So what is negative 3 bell? If you go back to your mathematics, you remember your mathematics, a reduction of a reduction of the logarithmic number into a 3 steps is equivalent to half power. So a negative 3 decibel come from the 0 decibel on the top is a reduction of power of 1/2. Yun ang 1/2 power is what you call is the basis of the bandwidth. Sa communication, ang tinatawag na bandwidth, that is the span of frequency wherein the power is reduced to 1/2 of the peak power. So kung alin ba ang power dito is 100 watts, nasaan anong frequency bababa ang power na 50 watts? So nandito siya. So you have a frequency 1, frequency 2. The second frequency is the highest frequency wherein the power is 50%, 1/2. So the difference between the highest power and the lowest power at that half power point is what you call your bandwidth. Okay? And ngayon, we have an example of an amplifier like this one, wherein this entire circuit serves as the amplifier of the signal that is being fed by the resistor here. Yung signal dito, papasok sa capacitor, and this will be the characteristic. And the signal here will cause the transistor to either switch on or off. And then depending on the polarity of the input signal, the output signal will respond. Okay? So the amplifier output will be collected at capacitor 2. Take note, C1 and C2 are present. Excuse. Ako. Upo na naman ang anak ko. Yan. Now, when we say cascade, a cascading is a process of successively increasing the signal. Actually, cascading can also take place when recessing the signal. But in the case, when we are amplifying the signal, yung maliit na signal dito sa amplifier 1 ay pinataas ng amplifier 2 at pinataas ulit ng amplifier 3 ng dito and so on. Ako. So finally, the output, the voltage output is present in this
and the voltage input is present here. In this case, there are A1, A2, and AN amplifier. So 3 amplifiers placed in order to cascade one another. The basic input signal is amplified, naging input signal ng amplifier 2, yung output ng amplifier 2 naging input ng amplifier A sub N, yung output ng A sub N yun nagiging final output. So, ito ngayon ang example ng cascading ng amplifier. So, basic signal, the generated signal is here, feed into the input resistor to the base, and then amplified. And then, the output is connected to C2 to enter the Q2. By the way, Q and 1 represent the transistor. So, finally, the output is obtained at B sub out. B sub C, B sub E, B sub CC, B sub EE corresponds to the voltage, the positive voltage at the collector, while B sub EE usually is the negative voltage at the emitter terminal. Okay? Now you can add another amplification on this for as long as the total output power will be within the limit of the current capacity of the transistor. Walang problema dyan. Kahit na gusto mo obtain ka ng, let's say, 2 amperes. For as long as kaya ng transistor, pwede yan. Output. Yan. Now, you will notice, in the configuration of the 3 transistor kasubago, when we talk about the beta gain, this circuit is primarily applicable for as a voltage amplifier, meaning to say, it is the voltage that you are being amplified. Now, it's also possible that it is the power that can be amplified. Okay? So, what is the implication? So, what circuit will be used on this? On this circuit. Now, another, tingnan mo, kung babalik kita doon sa basic ng amplifier, ito. The basic is that there is input and then there is output. Finally, the output is isolated actually from the input. Hindi na bumalik. Pag ilagyan mo dito, lalabas at hindi yun babalik. But there is the so-called oscillator circuit. An oscillator circuit is a circuit wherein the output, at the output of the amplifier, some signals, portion of the signal is being taken back and put it into the input. And that is what you call oscillator. Usually, an oscillator is a summing circuit to make sure that this output signal is being sampled. Kukunan ng sample tapos papasok doon. And it is being summed. The output is this time being compared with respect to the input. Okay, hindi yan, ang process is actually mixing or actually it is adding, but the process of adding the signal is not just to add the output into the input, no. The process is just to compare. So that pag kinumpare mo yan, sinam total mo, mangyayari, yun ang magiging input ng main amplifier. Yan ang ibig sabihin ng feedback. Okay? So, ito yung kuhan niya. Now, in the control electronics, we have the so-called transducers. What is a transducer? Kaya nga transducer, because it converts one event into another. For example, a piezoelectronic device transforms pressure into a voltage. So that's transducer. Okay? Ang iba naman, if not pressure, temperature. So if there is a change in temperature in the element, there is going to be a change in the voltage present. You know? Kanina, we can say that the photocell can also be a transducer by the presence of light, of visible light. It is able to convert a variation of voltage or current. Okay? So, yan ang... Ngayon, ito na. This is an example of the instrumentation. A thermocouple, that's a measuring circuit. A thermocouple is a temperature measuring device such that when the element or the transducing element, the transducer exposed to variation in temperature, the output will also vary. So here is the terminal block of the transducer. In this case, a heat is being applied at the transducer to make it hot. And if that is metal, the resistance will increase. So an increase in resistance causes a decrease in flow of current. And that flow of current will cause a change in voltage. Okay, this current flow will go there and then go and then. So that will be sensed at the monitoring device. In this case, a voltmeter. Yeah. We've been discussing kanina yung Ometer Voltmeter. Ito yung concept niya. There is an input and output probe for positive and negative probe. So you can select which one. So all are having an amplifiers. Actually, these are amplifiers. In order for that to be added, and then by selecting which particular amplifier, you will be able to reach the converter to be able to display. In this case, this is a diagram of an analog circuit. Okay, there is a constant source. If you bring this there, that source will feed, and that is going to be the... So, if the input is varied, naturally, the response of the amplifiers here will also vary. So, if the input, if you need a, say, 2 volts input, 3 volts input, 4 volts input, so you have to select the correct position in the switch in order to be able to connect, match the test probe to our particular function. Now, in here is the analog circuit, analog voltage. The analog is dependent on the electromechanical behavior of the assembly. Here, the positive and negative potential of the signal is being placed into the coil of the moving coil galvanometer, so that the amount of current there will determine the deflection of the magnet. Higher current, higher deflection, so this will deflect. Ito yung analog, ito ang analog circuit, analog meter. So ganito na, yan na. So an ammeter is also a moving coil, but this time the coil is in parallel to in series with the load, while a voltage meter is in across the load. Ayan. Ito baga, ni current in. This just pass, the coil in the instrument is in parallel with the shunt resistor. Here, the voltmeter is connected right across the potential. So the positive and negative potential is connected across the voltmeter. That is, The amount of current that will pass through the coil will depend on the voltage present across the line. Yeah. So anyway, this is an oscilloscope. An oscilloscope is already an instrument wherein it uses the flow of current to be able to transform it into a display. So ang nakikita mo dito ngayon ng gray, ito na yung output ng electron that is influenced by the behavior of the current in the input. Itong input dito, ipoprocess para may display. Okay? An oscilloscope purposefully just measures the amount of time in between the cycle. Okay, so beginning from 0, it will cycle down. So how many seconds will it need from here, and then signal go back to the 0 position? And knowing the time, you will be able to find the number of the frequency or the number of cycles it is going to take in a second. Now, the height from this horizontal line, the 0 line, the height going up or the height going down determines the amplitude. Okay, so sana meron tayo nito so that I will be able to demonstrate, at least ipakita ko anong behavior ng electrical circuit natin dyan. Okay, so itong circuit ng yung sabi natin kanina in the beginning we discussed the vacuum tube, the cathode ray tube. So this is it. There is an electron gun. Well, the electron gun practically is that source of electron wherein there is a heater to produce the electron, and the electron will be accelerated towards the the anode, the luminous spot here, so that when it hit the phosphor, it will light, it will give off light. Now the electron as it passes can be deflected by means of the magnet. Oh, di ba? Any manner, in any manner, for as long as it can deflect. It's either by a field or a magnetic field or an electric field which can deviate the electron to go up or go down. Hindi. Siyempre, pag na-deflect mo pababa, itatama ito sa baba na. Ayun na. So, ito ang circuit. Sinample, tapos para makita kung saan ipapasok yung, kung saan. Pag tinaasan mo itong platelet sa kanan, attract yung electron punta doon, pupunta sa kanan ng. This is the circuit of a cathode ray tube. This is a CRO or cathode ray oscilloscope. Practically a vacuum tube. Ito na yung construction niya. Alright. This is how a modulation in a broadcast radio. Normally, the signal in the, saan ba yun? Ito na lang, explain na natin. Normally, a signal is clear. Araw ka ini. The amplitude is the same amplitude, the same frequency. Now, if another signal is placed in the circuit, that signal, it's either to increase, that can affect the amplitude, okay? Pwede niyang pataasin ang amplitude, gaya nito, itong signal na ito, pataasin niya ang amplitude. Pero pagdating dito, pababain niyo yung amplitude. Okay? So, yung pagbago-bago ng amplitude ay nangyayari sa the same frequency. Kaya ito ang tinatawag na amplitude modulation. Pag tiningnan ngayon itong frequency nitong pagbabago, ano ang frequency nito? Yun na ang information na may ta-translate. No? Yan pumapasok, dinidecode kung ano ang lalabas na information sa yung AM region niya. Yan. This is an amplitude modulation. The frequency is maintained in the same frequency, but the amplitude is the one that is varying. In the FM, the frequency, the amplitude is maintained the same, but it is the frequency that is varied. Ayan o. Yung amplitude parehas, pero yung taas, I mean, yung frequency, ito masiksikin, tumaas ang frequency. Dito, mababa na naman. Okay? So, frequency modulated, ibig sabihin, it is the frequency that is being varied. So, if i-filter out ngayon ito, ang pagtaas, pagbaba ng frequency, i-filter out yan para mag-extract yung nag-influence na signal. Pag yan na-extract, ilalabas yan, yun na tunog. Okay? This is actually the so-called modulation of signal. When a basic signal that is generated by the oscillator is varied by the input, that is what you call modulation. Diba? We discuss here an oscillator. Itong oscillator, kung ang signal dito ay bumalik, tapos babalik, at pabalik ng pabalik, ano mangyari? Ulit-ulit ang signal na mag-iikot. So, if we allow this to continuously go round and round, this oscillator will produce continuous back and forth of the high and lows of the current. Kaya nga oscillate kasi pag oscillator baga pataas, pababa, ulit-ulit, pataas, pababa. So, pag mababa dito, itataas, kinuha yung sample na mataas, yung mapasok, bababa, tataas na naman. So, this is how oscillation takes place. Now, if this final output amplitude is the same, that output amplitude can be varied by way of modulating it by the frequency or by the amplitude. Kaya meron kayong tinatawag na frequency modulated FM or FM radio or amplitude modulated AM radio. Okay? So, sorry. Basta, my problem is every time the rain is impends to fall, naatsing ako. Siguro because of the vaporization of the environment. Kapag nagbago ang environment, may sangaw kung ano. Okay, so I think I forwarded the link that I shared to you here. I tried to explain the link that's available. So the second link that I shared is an introduction to uh, signal electronics. I hope uh, you will read this thing. Okay, so this the okay. So this is an example of a signal system. Oh, the analysis of a signal system. Okay, so this is signal system. In the signal system, we are interested on the time and frequency. Time, frequency, and amplitude are important when we say signals, uh, signal electronics. So this is the expression of those. Ayan, analog signal. Then digital signal, a difference between analog signal. An analog signal is just often this analog signal occurs in a cycle. A cycle in such that the frequency domain is the same. Okay, in this case. And the behavior of the current or voltage is either in the form of sinusoid, or in the form of sawtooth, other uh, other other waveform. And the common thing in those signals is that it is a cycle. What is a cycle? A cycle is such that the value goes to the highest peak and then continue down to zero. From zero goes to the negative peak and then go back to zero, then go positive and so on. That is an analog signal. So an analog signal always have a positive and negative value. Okay? Positive, negative value. So again, as a cycle, that goes positive, that goes negative, continuously round and round all the time. Now, a digital signal is different because a signal can only be either plus or minus. When a voltage goes to zero, that means it is 0 volt. No negative value here. So, if a signal is only limited to have a peak of about 5 volt plus 5 volts, when it switches on, it goes to immediately 5 volts. When it switches off, immediately. So, a 5 volt can be read as 1 and a 0 volt can be read as 0. And this alteration of 0 and 1, 0 and 0, 1 can be a code in order to be transmitted so that it can form as a form of information. Okay? Yan ang pagkakaiba ng. So, this is now a continuous signal. Now, okay, so friends, I think I want you to I just want to browse this link. I think this can help you a lot in understanding our topic. After all, This is actually not the main content of the subject, but just for the sake of introducing to you how signal works in electronics and what is signal all about, especially when um, nowadays we are always living in the digital world. At least we are able to understand what's the digital signal, what is an analog signal, so that if we are given the task to do, especially to work on controls, then we know if the signal is analog, if digital, and how it behaves. Okay, so here, yeah, this link will, I think this will help. Now there is another term here, is an operational amplifier. What an operational amplifier is, this amplifier composed of many amplifiers, uh, cascaded as we discussed before. And finally, there are only three terminals in it. One input one, another input two, and then the final output. So input one and output two can be compared, and if they are compared, they will produce, the amplifier will produce a different output. Okay, so for example here, when the signal goes on in the positive non-inverting signal, a positive input signal produces a positive input signal, positive output. An inverting signal, inverting amplifier, a signal, a positive signal at the input produces a negative signal at the output. So two types of operational amplifiers are the inverting and the non-invert. This is the non-inverting and the inverting amplifier, operational amplifier. So this now here is a comparator. It is the signal is uh, introduced into a summer, and then both fed into the uh, inverting and non-inverting. So this is now it is just amplified, tumaas lang. Now if the two different signals are placed here, the result is depending on the uh, configuration of the operational amplifiers. Okay, this is the principles. You read this. Okay? I don't think so. Now, in the amplifiers, there is a feedback, so-called positive feedback. There is also a negative feedback. Okay, so this is a feedback loop, output going to the input. So I hope you just read this link. I share this to you. So here. So not so much of this because kailangan naman nakabasa. Nandito naman lang. Hindi ko na-explain ito. Okay? So I just leave this to you to browse, and then for your reference, yan. Okay, so ito. Maybe next meeting we will discuss the field effect transistor circuit. Okay? May iba tayong mahiling duman sa field effect transistor circuit. Ngayon, most of the principles that we touch are on the bipolar junction transistors. Those circuits making use of the BJP, kasi that the behavioral circuit is slightly differs from that of the, especially the metal oxide silicon field effect transistor or the MOSFET. Okay? Now, I'm not going to hold you for long. I think mag-rest naman ako ng konti, 2 hours. Maybe I can, maybe I will ask you to answer some question next meeting. Okay, okay ba? I will ask you, I just want to know how far have you kung gaano naiintindihan ng display dito. Alam niyo talagang totoo nahirapan ako dito mag-computer. Pero ako buang. I feel like I'm a fool just talking and talking and then I don't know what's you know, I can't tell what's your response on what I'm talking here. Anyway, maybe next meeting I'll ask some question to be able to know how how far you understand how the subject become interesting to you. So I will ask you a question. Okay? Nagsimula na mag-ingay dito sa kapitbahay, may patrabaho. Okay, I'll say now thank you and let us say the prayer for Ukraine, for peace in Europe, that we ask God that this chaos will not prolong, that it should stop right away, because there are people dying, there are people beginning to be miserable. May mga namamatay, marami namamatay. Supposed to be, hindi naman dapat sila mag-iwal ba ko? If you think about the situation in Russia and Ukraine, why should they be fighting against another when they are not experiencing poverty? They are rich, mga mayayaman sila, pero bakit kailangan pa mag-away? See, yeah, that's one of the agonies of life. When you are supposed to be living in comfort, you are supposed to be living in peace, because everything is well provided for. What? Money, fuel, gasoline, ang yaman nila. Tapos mag-away. Kita naman sa Pilipinas, we're struggling. We have a political struggle because what happens here, the crisis in the Philippines is about the truth, about the lies. We are having conflict in the Philippines because of, some people do not want to speak about what is true. And some people would insist that this is true. So where are you going to? For me, I have to side with what is truth, what is the true thing that happened. Because it is a shame, it is a shame to continue to believe in a lie. I live in a time when martial law took place. And since 10 years old, until now, I'm aware of what's really about that history of martial law. So I understand it was a bad kind of, it was a bad time for the Philippines. Kung na-brainwash kayo, maybe you can start for the second time to research, magtanong. Kasi, the reason why we were given intellect and free will, in order for us to correct the memory. Kung mali ang naintindihan mo, mali ang memory mo. Pero kung mali ang naintindihan mo, mali na sa memory, meron tayong capacity. We have the intellect to understand, to try to know what is talagang totoo. Diba? Ngayon, pag benefit mo, anong pinaniwalaan mo, yun na yun. Hindi mo pinakinabangan ang pangatlong attribute ng tao. Alam mo, ang tao ay binigyan ng tatlong attributes. Number 1 is intellect. Yung marunong ka mag-isip, talino. Number 2, freedom. Yung free will, kung anong gusto mo, yun talaga. Yun ako, sa'yo yan. Kaya kung piliin mong mali, mali ka talaga. Piliin mong tama, tama ka. Pangatlo, binigyan ka ng memory. So kapag inalis mo ang isa dyan, binigyan ka ng talino, pero pinili mo yung mali, ano yan? Kaya mo bang burahin sa memory naman? So let's pray for the, for a peaceful world. In the name of the Father, and the Son, and the Holy Spirit. Amen. Our Father who art in heaven, hallowed be thy name. The kingdom come, thy will be done on earth as it is in heaven. Give us this day our daily bread, forgive us our trespasses, as we forgive those who trespass against us. Not bring us to the test, but deliver us from evil. Amen. Hail Mary, full of grace, the Lord is with thee. Blessed are you among women, blessed is the fruit of thy womb, Jesus. Holy Mary, Mother of God, pray for us sinners now, at the hour of death. Amen. Glory to the Father, and to the Son, and to the Holy Spirit, as it was in the beginning, is now, and ever shall be, world without end. Amen. So, friends, thank you for coming over, for joining the meeting. I wish you everybody in good, in safest condition, in the most helpful way, in a helpful life, and a happy life. Okay? So,